Hello team, today's challenge is best hand, where we're given a poker hand, 5 cards, and we need to figure out which of these different types of hands we actually have. So this is from low to high. There's high card. Every hand has a high card, right? Just might not be the high card, the high card for the round, right? Then there's pair, 2 pair, 3 of a kind. Down here is 4 of a kind, full house, straight flush, and royal flush being the best hand. Okay. I'm actually going to flip these around in a few seconds. You'll see that. But we will be able to do this. And there are a few steps in here where we have to test pretty much each one of these things individually to figure out which one we have. And that's my preferred way of doing it. If we try to load the function, this single function with all the different parameters for which one of those it is, it's going to get messy in a hurry. It's going to get very long, and it's going to be very hard to debug if something goes wrong. So my preferred way is to break it apart, just like you've seen me do in the past, and that is what I'm going to do here, okay? So on that note, I'm going to start out by creating a hand. This is what's going to be our final hand, so we're actually going to return this, and it is going to be equal to a class. So capital P poker dot get hand. And you'll notice that there is no new keyword here. I'm actually calling this as a static method. So today we're going to use a lot of static methods as a way of getting around having to instantiate. Otherwise, I would have to first do poker with cards, and then I would have to call hand.getHand, right? And it feels very noisy that way. So this allows me to go direct to the source. It does mean that I am operating inside of the class itself and not an instantiation of that, right? I didn't set that up as a separate thing with its own state. So we can't actually maintain state. That's something that we'll have to work around. But for today, we don't have to worry about that. So fun times, okay? But down here, we could go hand, or we could just return that directly, whichever you want, and get started, okay? So that class looks like this, and I've already set up some data so you don't watch me typing all this. It's a lot of extra work, so let's quickly talk through it, and then we will write the code that uses this data, okay? So class of poker, again, we aren't calling that with a new keyword. We're just going to operate inside of this frame, which allows us to, if I had to, when it's all said and done, I can just grab this whole class, move it to a different place, and use it again, okay? So the flexibility of turning it into a library or something like that is right there, okay? Our first one is a capital M map where we have all of those values, and you can see that I started with the best and I went to the worst, okay? That way I can loop through these, and that's the plan with the capital M map, is that I'm going to create a loop that goes through each one of these. It has that key name. It also has a method that we have not created yet. So I'm going to test my values against is royal flush. And if it returns true, then I send this as the return, right? I return that directly. Same with straight flush, 4 of a kind, all the way down to 2 pair and 1 pair. And if nothing else, I return true every single time for high card because there should be one. It's a way of saying that I basically have nothing, right? Like high card is me getting very, very lucky in terms of poker. So always returning true on that, okay? But that's what we're going to do. We're going to write all these methods in a little while. They aren't actually there yet. And down here, we have our value map. Now, our value map helps us to sort and play with the data. So because we have a mix of numbers and letters, we need a way to represent those in a sortable way. Could we use UTF-8 and character code at, something like that? Probably, but it would be more math. So setting this up as a one-time tool and doing it, most of these represent themselves, but down here we have the T, the Jack, Queen, King, Ace, all as their represented numbers, right? Not true numbers, right? These numbers don't mean anything in terms of poker or most card games, I believe, but they allow us to, again, work with the data. And in fact, the way that we're going to do this, I could actually send through the number 10 as well. and it will work exactly the same. Not a problem. So I'm going to turn that on. You're going to see that everything just works. We don't actually have a test for any of this, but it will, okay, because of how we write the code. So down here, we are going to build get hands. That's going to be our first method on here. We're going to do that. It is going to be static, right? Because everything is static today. So we're going to get real good practice at using that static keyword, okay? And then down here, the first thing that I want to do is parse the data, okay? So parse is going to be equal to this, a private method on that called parse cards, like this, sending through cards, and that's going to return data that we can use in all of our different tests, okay? So we're going to try and format it in a way that makes sense to us right out of the gate, and then we're going to pass that in to all these different tests and find out which one is true, and that's going to be our return value, okay? Which is the next step, right? We need a loop. So right here we have that for loop. We let this. We have the name and the test, and that's going to be from this dot. What did I call this? Hands lookup. Copy and paste it down. Brilliant. Okay. And then inside of here we run that test. So it's going to be test. You need the not those. You need parentheses after it to actually trigger the test. Right. Very important. And if it returns true, right? If that test returns true, then return name, right? That's the whole of get hands. Now we need to take care of parse cards, okay? So that method can go right above it, right here. Again, it is static. We paste it in, we add some curly brackets, and this does a huge amount of work, right? We need to know all of our values. We need to know all of our suits, and we need to know some counts, right? In order to determine if we have pairs or some sort of multiples of values, not suits, but values, okay? So this parse cards does a lot of the work that makes our life easier later on. We start out by returning directly, okay? So we get those cards, and what are we doing? Well, we are reducing them, okay? Not returning, sorry. I'm going to capture that, my bad. Jumping ahead, parsed equals cards. That's what I wanted. Cards.reduce, okay? And inside of here, we throw all that data at it, and we get back a new set of data. And that's really key to what we're doing here. We do need to do an extra bit of work after, just a couple lines, but this gets most of it done, okay? So inside of here, we're going to do that. We always return the accumulator because we're good like that. And inside of here, our initial value is going to be an object. That object is going to have the suits like this. Suits, if I could spell it. There it is. It's going to be an empty array. And then we have the values, which is going to be an empty array, and the counts, right? The counts are how we determine if we have pairs. It's just easier. It's just easier for us to sort out. So counts like this, and that is going to be an object because we're going to fill it with data, okay? We can't just fill it with the number of items because we need to know which is which, right? So we need to do a little bit of extra work, which is why down below we need to do extra there too, okay? Okay, here we are. This is the reduce, right? This is, again, it's the bulk of the work. It's the heavy lifting that makes everything else really, really easy later on. So we're totally going to do that. And that starts out with getting the value. So we get value. It is going to be based off of this value map, okay? So we're going to grab that and go this, with the dot, don't forget the dot, this value map. And inside of there, we're going to go current.slice, and we're going to slice from 0 to -1. And this is why we're able to have the number 10 and the letter T both equal the same thing, because we're basically saying grab everything except the last letter, right? That's our value. So we get that. We get back a number that is possibly 10 and 10, right? 11, 12, 13, 14, all the regular numbers, and we use that, okay? Accumulator values, right? Dot push, just like this. And what are we pushing? Well, we're pushing that value, right? Down below, we go accumulator suits dot push, right? Very similar thing where we do current dot slice, and this one we just need -1. So we're starting at -1. We're going to the end. It's only one character. Brilliant. Okay. And then those counts. So the counts are a little bit weird because we go counts for value, not for current, for value. We want the number, not the letter. Okay. So with that, we can grab this and we do an assignment, but this might be undefined because it's an empty object, right? So we need some nullish coalescing in here for the 0, and then we add 1, right? So we are rolling up whatever this count is. If we have like 2 aces, it's going to be 14 twice. So the first time I'm going to find a 14, it's going to add it. It's going to add it to the counts and increment by 1 so that we have 1. If I have 2 aces, right, then the second time around, it's going to go, oh, I already have it. So it's 1 plus 1, which is 2. Okay. Again, a lot of work happening in this reduce, but it gets us the data that we need to make our lives easier later on. Okay. But we aren't done. So down here, first off, we can return parsed. Okay. But before that, we are going to sort. We're going to sort 2 things. So that parsed, now that we are outside of the reducer, so parse.values.sort, and sort is in place. So we don't need to reassign or do anything like that. Instead, we just pass it the function and it gets it done. So A and B, and we want it to be from low to high. So it's A minus B, just like this. And then of course we do the counts, but for the counts, I don't actually care about the keys. They were only there to help me with this. Now that I'm outside of it, I only care about the values, okay? Which means that I'm going to do a reassignment here. So parse.counts equals object.values parsed.counts, okay? With this, I get an array of those numbers, but I also want to sort that. So I'm going to do that right here. And I want to sort that from biggest to smallest. This is going to let me know if I have 1 pair, 2 pairs, 3 of a kind, 4 of a kind, full house. That's what this part is doing for us. Okay. For the flush and the straight and stuff like that, we use suits and values, but for the matching pairs, we use counts. Okay. And we only care about the values, not the keys, which is why we got rid of them. So right here, it's a similar thing where we go A and B, and instead of A minus B, we do B minus A, right? We reverse it so that it's there. That is a lot. So taking a look at it, again, we map everything to one of these values inside of value map, okay? That's going to let us do the work for our straights, right? For the straights. We also sort out all of our suits. That's going to let us know if we have a flush, right? We're going to sort that out in a few seconds. And then we do the counts, which allow us to figure out if we have matching pairs. Okay. A lot of work, but that's how I'm doing it today. Okay. So with that, we get all that back into this parsed, which we toss into this function, and it runs. Now, with all that done, we can go and create our tests. Okay, so I'm going to grab all of this, that, Command D, all the way down, grabbing all these, and then jumping to the end, copying, and bringing them to the bottom of my class. That's right before this yellow bracket that I got. But pasting it in, giving it a little nudge here, and doing some work. Okay, so again, I'm going to multi-cursor this. Grabbing that dot, we're going to set it up as static, okay? Is royal flush, we're going to jump to the end, add some brackets. We're going to send in that parsed cards like this. Naming things is hard, pick a good name, and return true. It's not always going to be true. We're about to update these, but for now, it's a bit of a placeholder, okay? So now we have all of these test functions set up, okay? At this point, we can start from the bottom and work our way back up, because the pairings are actually the easiest thing to do here. We've already sorted it out with all of our counts, so we can do that just like this. We take that parse cards, we get the counts, right, from 0. So we get the very first in that array, because of how we sorted them, that should be 2, right? If it's only 2, and we've hit is pair, because we're going to test everything else first, right? But if there's only 2 in here, so we can set this to 2, then we have a pair, and we can return true, which is what the triple equals does here, okay? With that in mind, we can do the same thing for is 2 pair. So we do this, and we do it again, but for position 1, for index 1, okay? Again, if it was 2 pair, our counts would be 2, 2, 1. It has to be, because it's 5 cards, right? So there's going to be 2 cards and 2 cards, because they were unique values, and that's the key. If it was 4 of a kind, then we would have 4 and 1, right? Because there would be 4 cards that have the exact same value. So we can actually go and do that right up here, 4 of a kind, pasting it in. This should be 4, right? Which is perfect. 3 of a kind is the same. It's 3. Excellent. In fact, full house works exactly the same way. So it is 3 of a kind and 2 of a kind, right? That's a full house. So we can go and paste this in, changing this one to 2 and the index to 1, okay? Hopefully that's making sense. It leans heavily on the way that this counts array has been generated for us. It was originally an object. We took just the values, and because of how we sorted the values, these numbers work beautifully, okay? So with that, we have is flush, is straight. We should take care of those. Is flush is really, really easy. We just go new, set, tossing in that parse cards, so we can grab that. Dot suits, right? So this is where the one time that we use suits, okay? And we get size, not length, but size. Set uses size, making sure that that is now equal to 1, right? That's the flush, right? If we have, because set doesn't allow duplicates, if we reduce this array down to 1 item, then they must have all matched. So that works. Straight here, very much the same. So, sorry, not very much the same, but a little bit more, okay? Is straight is our most complicated test because of the nature of it. So we get the values this time, right? We use the suits there. We're using the values here, and we do every. Now, inside of here, we're going to get the value, just like this, the index, and the array, okay? This saves me from having to pass in parse cards values inside of the callback, so I can use array directly, okay? But right here, we drop down and we return directly. What are we returning? We're going to operate on the idea that the current number is the previous number plus 1, right? The current number is the previous number plus 1. So if my current number is 6, then my previous number should be 5, right? Hopefully that makes sense, which means that if I am on index 0, the very first element, there is no previous number. So that should just be true, which is what we do here. If index equals 0, or if we do the thing, if value is equal to array index minus 1, right? Because we're going backwards, and we take whatever that value is and add 1. Feels a little bit weird, right? Index minus 1 is for the index that we're attacking inside of array. And we get back the value from that index and add 1 to it. Okay, that's don't think that we could get away with minus 1 plus 1 inside of here or something, right? It just doesn't. It wouldn't work. It wouldn't work. With that, we need one extra test. Okay, and that extra test is what happens if we have a low ace straight. So ace 2, 3, 4, 5, right? Currently, the ace is valued as 14. If we scroll all the way up, 14. And our low A straight, because of how we sorted the values, would be 2, 3, 4, 5, 14, right? There's a huge number in there. You might think, okay, I'm going to add 9. Maybe I add 9 to 14. But what happens if I add 9 to, add 9 to 5 to get 14? What happens if I add 9 to 3, right? Well, that would give me 12. If I have a 12, now I am messed up. I'm in a bad spot. So we cannot do it inside of the every. Instead, if I scroll back down, where did it go? Instead, I do that outside of the every. So I go here, add an or, getting that parse values again, and joining, okay? Now, if you want, you can add a comma, right? By default, it is a comma though. So you can actually just leave that off and set that equal to 2, 3, 4, 5, and 14, okay? So if it's a straight or if it matches this, then it's the ace to 5 straight, right? It's the low A straight. Excellent. With that, we can actually use these two things inside of straight flush, right? So we could go is flush and send through the parse cards, right? Just like this. And where is it here? And is straight, just like this, pasting that one in. This dot, getting to this. Hopefully I didn't forget that anywhere else. We'll find out in a second. But this dot is flush, this dot is straight. And normally this would work, but because of this, the way that we've set up our statics and the way that we are attaching them to this map and then calling them down inside of this loop, at some point it loses the this. Okay, it forgets what this is, and once we reach the is straight flush test, it will complain that it doesn't know what this is. The way that around that is to reattach it. So up here we could go this.royalflush.bind this, right? We could absolutely do that. The easier way is down in the loop to call. So we call, and then inside of our arguments, we leave parse there. But before parse, we go this and then parsed. And that gets the job done. That reattaches this, the poker instance, to whatever test I'm calling. So just a little extra thing there because of how it's dropped the this keyword by the time it gets into this loop. Okay. But that takes care of that. So we check if it's a flush, we check if it's a straight. If it is, then it is a straight flush, right? Same thing here where we can grab this. So this dot is straight flush and we toss in parsed cards. We are on the home stretch now. In order for it to be a royal flush, it needs to be the 10 to ace, right? 10 jack queen, king, ace. It skipped a beat in my head there. So in order to check that, we could actually do something very similar to this, right? We could run this up as an option. Where did it go? Right here. So, and bringing it in, pasting it, and changing this so that it is 10, 11, 12, 13, 14. And that should work. It absolutely does, amazingly. I thought I might have dropped one of these thises. So I'm glad it is working. Another option is just to test if our first number is 10 and our second number is 14. Okay. So for that, I can skip this and come down and go parse values, just grabbing that, parse values of 0 equal to 10, and lots of pasting in here, parse value of 4 equal to 14. Okay, and this should also work. This gets very noisy and you can see the line wrapping. So my preferred method is to go up and do this const first, and then you need 4 of these commas and last. Okay. Essentially what you're doing is you're going first, then you're skipping the second, the third, the fourth, and giving you the last. And you get that from these parsed values, right? And then from there, you can change this to First equals 10 and last equals 14. Okay. And it should still work. In fact, if you want to go further, one thing that you could try, and I'm curious if this will work now that I'm thinking about it, is instead of this, you can actually destructure an array in an object-like way. So one thing that we can do is we can bring in the curly brackets. We don't need all of them. And we go 0 and change it to first, and 4 and change it to last. And this obviously works, okay? That was a lot. And it's, it's getting to be a lot of code. But I do prefer this way because it lets me work on the individual pieces. And I could really go in and test each one of these functions if I had to. So to bring it home, right? We are, in our main function, we did a static call to this getHand method, I don't know if I meant to do that as plural or not. I did do it right up here, so I guess that's okay. Yeah, getHand. Cool. So getHand off of our poker class, okay? It is a static method, which is why we're using static keywords all over the place today. Instead of instantiating and then having to call like hand.getHand, something like that, we don't need to do that. We can just do it this way, right? We don't need to maintain state here, okay? And then from there, we created our class, which I just brought in and added some data, which these keys and these the values for these keys are function calls or function declarations, right? We don't actually call the function. So no parentheses on these ones, but definitely down below, okay? We have a default value, which just always returns true, right? So that's going to be our default, which is why we don't need anything special outside of our loop. You could, right? You could return anything, but you should never hit that state, okay? Because of the way that the loop works, okay? And then we have our values, and the values are strictly there to help us with some of the math and some of the sorting, right? That's the real thing there. So this is just to help us work around the fact that we're working in numbers and letters. Could we have done it a different way? Maybe. Would it have been an extra math? Definitely, right? But from there, down here, we use that getHands method and we parse out our data, which does a whole lot of stuff inside of the reduce and then a little bit of cleanup afterwards so that we don't have to think about that ever again, right? Once we get this set up and test it out and work in the way that we want, we can just use it everywhere. And that's exactly what we do, right? We send that parse data into each and every test. We did have to bind because of the way that it drops this with the way that we set it up, but we pass that value into each and every test. So each and every test looks like this, starting from the bottom to the top. We check for pairs using the count, check for 2 pairs, check for 3 of a kind, checking for a full house or 4 of a kind, right? All those pairings, all those card pairings, right? We check for all of them using that counts object or that counts array that we created, right? And then, of course, our flush. So our flush was really, really easy. We just parsed it out and did it. Now that I'm thinking about it, we probably could have had this as the set. Where is it here? Right up here where we have suits. We could have just had this one as a set and been done with it because we don't actually do anything else there. And then just testing for the size of it later on. Maybe a little performance optimization. I don't know. But is flush using that size parameter, is straight doing a little bit of work to make sure that the numbers are incremented correctly, or if we have a low A straight, checking on that, right? And then using these methods up here inside of straight flush, and again, a little bit of creativity in is royal flush for the win, okay? It was a lot. Like, if you didn't get it the first time, definitely watch it the second time on 2 times speed or something like that, and ask all the questions inside of the comments. In fact, if you liked it or hated it, right, Again, I like breaking all these little functions out into their own thing because they feel easier to me, right? It does mean that it's more lines of code, but lines of code isn't a good metric for a dev anyway. So I wouldn't worry too much about writing too much, right? Unless it's too much slop. But that's a different conversation. With that, this is it for today. Not every solution, just hopefully one good solution. If you liked it, if you hated it, if you found a different way that you want to share, hit me up in those comments. Otherwise, today this has been Best Hand, and I will see you tomorrow.